In this series of finding inverse functions, I am taking up some examples which involve quadratic functions. Now I've seen students really, struggling to get this. So I thought that let's start from the very basics and give some examples, and I hope those examples help them. So the question here is, consider the function f of x equals to 2x squared minus 6x. Find the inverse of the function. Write domain and range of the inverse of the given function, and how can you restrict the function to ensure that its inverse is also a function. Now these are common questions which are always related with quadratic function, and so we'll consider some of these and hope it helps. Now the function given to us is f of x equals to 2x squared minus 6x. Now if I interchange x and y and try to solve for y, it will be very difficult. So I need to convert this equation into vertex form. So that is kind of key here, and this is what I am going to concentrate on. So first, let's understand how to do completing the squares. So for that, the process is you need to factor the leading coefficient, which is 2 in this case, and write the rest of the terms with x in the bracket. So we get x squared minus 6 divided by 2 is 3, and we get 3x. We are not factoring x, right? We are factoring only the leading coefficient, which is the number 2. Now the next step is to find half of this number and add and subtract square of that. So half of 3 is 3 by 2. So we will add and subtract 3 by 2 square. So this is, when you are adding and subtracting the same term, you don't really change the equation, right? But it helps in a way to complete the squares. That means these three terms can now be written as x minus 3 by 2 whole square. So I can write this as 2 times within brackets x minus 3 by 2 whole square. And this term is minus 9 over 4. 9 over 4, right? So that is how we get this equation. Now, if you are wondering how to get this, one thing you should remember, what is a minus b whole square formula? Let me explain it here. So if we have a minus b whole square, it is a square minus 2ab plus b square, correct? Now you will see here, this is a is x for you, think like that, and b is 3 over 2. Now what is 2 times x times 3 over 2? What I'm saying, what is 2 times, in this case, x times 3 over 2? It is 3x. Do you see? It is 3x, the term here. Do you see that? With minus sign. And 3 over 2 is the b value. So we constant 3 over 2 whole square. Do you see that? And instead of a, we have x squared. Therefore, this forms an equation can be now written as a minus b whole square. So now compare it. So that is a perfect square, right? That is how we do it. Center term is twice product of these two, and therefore we did half of it. So that's the logic. Now once we are done completing the squares, then we will open this up. That means open the brackets, distributive property, and write down the function in the form of vertex, right? So here 2 times 9 is 18, or you can divide by 4. So we get 18 divided by 4. Let's write it in fractions. So you can write this as 9 over 2. So that becomes our function in vertex form. Now you can do inverse of this function, right? So what we will do to find inverse, this is y equals to this. So we'll follow the standard method, interchange x and y, and then find the inverse. So let's do interchange and find how to do inverse. So first step is swap x and y. So we'll write x equals to 2 times within bracket y minus 3 over 2. You can write 1.5 here, minus 9 over 2, and you can write 4.5 here, right? Okay. Now from here, what we can do is we'll bring this term here. So we get x plus, let me write 4.5 equals to 2 times y minus 1.5 whole square. Next step is divide by 2, right? So we get x plus 4.5 divided by 2 equals to y minus 1.5 whole square. Now this is a critical step. Now we need to find what y minus 1.5 is. So we'll square root both sides. Remember, when you do square roots, you have to write plus and minus. Don't forget that. See, square of negative number is also positive. Therefore, we write this as plus and minus square root of x plus 4.5 over 2 equals to y minus 1.5. So this is a step where students can make mistake. Don't do. Whenever you square both sides, we are considering both plus and minus signs. Right? Now you bring this term, and so we get plus and minus square root x plus 4.5 over 2 plus 1.5 equals to y. So we have isolated y, but you need to do completing the squares. And after this, you can write inverse of your function. So inverse of our function in this case is plus and minus square root of x plus 4.5 over 2 square root plus 1.5. So that is how you are going to find the inverse of a function. If you don't do completing the squares, you can't really isolate y. So remember, you need to do completing the squares and then find the inverse, right? So that is our inverse function. Let me write down this inverse of the function. I'm not writing x here since this is not a function. It is a relation, since for all the values of x except minus 4.5, the function has two values, right? So it is not a function, right? So it is just a relation. So we write f inverse is equals to plus and minus square root of x plus 4.5 over 2 plus 1.5, right? Okay, so I use different ink. I hope it's not getting mixed up with that 3x. Okay, so we found the inverse. Now we need to write domain and range of inverse of the given function. For domain and range, I will recommend when you have these functions, right? So we can really sketch them. Just kind of sketch this function. Now as you can see from the completing the squares, that vertex of the function is actually at 1.5 plus and minus 4.5. So it's kind of here, right? And second, you could also factor it. So if you factor it, let me write that in factored form also. You could do 2x, and what will you get? You will get x minus 3. So the graph actually goes like this, right? Now you can see from the graph and even from your equation here that what is the domain of the function? The domain of the function, this is x belongs to real numbers and y belongs to real numbers, but y is greater than, y belongs to real numbers, but y is greater than equal to minus 4.5, that is 9.5, 9 by 2, minus 4.5. So this point for our function is minus 4.5, right? So the range is greater than this. When we do inverse of a function, what happens? Range and domain changes, correct? So what really happens is that the domain becomes the range of the function, right? So domain for us now is equal to x belongs to real numbers, so that x is greater than equal to minus 4.5. You see that? That is the domain. And the range is y belongs to real numbers. So for the inverse of the given function, domain and range swaps. So that you could have done even without doing all this. Why am I saying this? Like if you do something wrong here, then at least you can get the other two right. That's the whole idea, you know. every part counts. Every part counts. And what we are doing now is preparing for test. I've seen my students sometimes they'll make a mistake here and then they'll end up answering all three parts wrong. But well, this I made independent. Find the domain and range of your function and swap them and write down as your answer, right? Once you find inverse, you can always find domain and range, right? Now from here you can say that the restriction is actually in the domain. The square root term should always be greater than or equal to 0. It cannot be negative. Do you see that? So from here we know x plus 4.5 over 2 should be greater than or equal to 0. So let's do that part now. So we have x plus 4.5 over 2 greater than or equal to 0. That gives us x plus 4.5 is greater than or equal to 0 multiplied by 2. And then x should be greater than or equal to minus 4.5. So you get the same domain. Do you see that? Same domain, right? And range, of course, there is no restriction. Plus and minus, so it's like a function, going all over. So that's not a problem. You could do from here. But my recommendation, strong recommendation is find domain range of your function, swap, and write down domain and range for inverse of the function. At least you ensure correct marks for part B. Now, third question is, part C. How can you restrict the function to ensure that its inverse is also a function? So best way is go with the vertex. So you know the vertex you could find from here. Vertex is at center of two x intercepts. The vertex here is at center of two x intercepts. One is at 0, one is at 3. So the vertex is at 1.5, 1.5, correct? Vertex is at 1.5. So if you consider only one part of the function, that is, if you restrict your domain this side of the vertex, that is, if I say that let x be greater than or equal to 1.5, that means I'm restricting my graph to only the portion highlighted. And then its inverse will be a function because it will not fail horizontal line test. At present, the function is failing the horizontal line test, right? If I draw a horizontal line, it strikes at 2 points. So that is one alternative. Second is, I could have said x less than 1.5 or less than or equal to 1.5. So there are two options. Now these options are important. If I take x less than 1.5, then I'm considering the negative part of this. And if I use x greater than equal to 1.5, then I'm considering the positive part of my inverse function. I'm adding all these informations because at times in the test they may ask you what is the inverse. They may ask this question first. Restrict your function so that its inverse is a function. And then they may ask what is the domain and range of the restricted function and its inverse, right? Then you need this help. Now here I'm closing this with all this information, and for you the question is, as I said, the question for you is part D. Let me write down. I know it's like messy already, so there is no harm in messing it up further. So we say part D is restrict the domain of your function so that its inverse is also a function. That is part D. And part E is find domain and range of the function, restricted function, and its inverse. And its inverse. Do you understand? So part D is restrict function, right? So that its inverse is also a function. And part E is find domain and range of both function and its inverse. The restricted function and its inverse. Do you get my point? Answer these two questions. Thanks and all the best.